GMAT all day.
The one thing you will hear me repeat throughout the remainder series is that remainders are patterns. And in order that we can start to uncover what some of those patterns are, I have written out here a sequence of consecutive integers starting at a more or less random spot. And so let's just see what we can uncover about remainders when we divide all of these numbers here in sequence by, we'll just say, by 5. And so here, 12 divided by 5, this would be what? This would be 2 remainder 2, right? So 13 divided by 5 would be 2 remainder 3. 14 divided by 5 then would be what? This is 2 remainder 4. And so we can start already sort of seeing a pattern emerge in our remainders as we go from 2 to 3 to 4. But then what happens when we get to 15? You would not call 15 over 5. You would not call that 2 remainder 5, right? You would say this is 3 remainder 0. So our pattern here is broken. So let's keep going and see what happens. So 16 over 5. This is now 3 remainder 1. And 17 over 5 is 3 remainder 2. 18 is 3 remainder 3. And so our pattern is starting back up again. 19 over 5 is 3 remainder 4. And so now you can maybe predict what will happen when you get to 20. 20 over 5 is not 3 remainder 5, right? It is 4 remainder 0. And so we have this resetting, repeating pattern. And so 21 over 5 is going to be another remainder 1. 22 over 5, 4 remainder 2. 23 over 5, 4 remainder 3. 24 over 5, 4 remainder 4. And then 25 over 5 gets us to 5 remainder 0. So you can see what is happening here. Our remainders are going up in sequence, and they begin approaching our divisor. So in this case, our divisor is 5, but it never reaches the divisor. In other words, this illustrates one key property of remainders, and that is that your remainder must always be less. And so I'll double underline that, because it cannot be equal to. Your remainder must always be less than your divisor. Your divisor being the thing you are dividing by. So the fact that it must always be less, that is why, if it could be equal to your remainder, then in this case here, you would say 15 over 5 could be 2 remainder 5. But of course, that is not the case. And that is because your remainder must always be less than your divisor. And so once you get to 4, then your pattern has to reset. And so why is this important? So what does this mean for some of the properties of your remainder? So if you are dividing by 5, it could be any set of numbers. What are your possibilities? What are your possible options for what your remainder could be? Well, since your remainder must always be less than your divisor, your remainder could be 0, 1, 2, 3, or 4. And likewise, and so don't forget the 0 is a possibility. So when if you're dividing by 6, your possible remainders are 0, 1, 2, 3, 4, or 5. And if you were dividing by 100, your possible remainders are any integer from 0 to 99. And so you can maybe start seeing why this could be relevant to the GMAT, because on something like a data sufficiency question, if they just say, for example, if they just give you a question that says, what is the remainder when x is divided by 5, and they don't give you any other information. So if they were to do that, you might say, well, it seems like they're going to have to give us a lot more information because we have infinite possibilities with just the question, but that is not really the case. And so with remainders, because remainders are these repeating patterns, they just ask you, what is the remainder when x is divided by 5? You start with a very limited set of possibilities. And so not only does your remainder have to always be less than your divisor, the possible options for the number of possible remainders, that is always going to be equal to your divisor. And that is because Don't forget the zero. Because of that, we only have 5 possible options for what our remainder is here. And so if they were to say just something like the remainder is odd, well, that automatically narrows it down to just 2 of our possibilities. Or if they were to say your remainder is a multiple of 3, that's only 1 possibility. And so knowing these properties of your remainders can help to significantly limit the possible answer choices for remainder questions. So let's take a look at a question now that tests some of these properties. M, N, S, and T are integers greater than or equal to 0. When M is divided by 5, the remainder is N. When S is divided by 12, the remainder is T. Which of the following could not be the value for N times T? So here, it might seem like, so we got 4 variables, right? M, N, S, and T, without really much information about any of these things. And so if you're trying to set up equations here, or if you're trying to solve for anything, or trying to do too much algebra here, you might run into problems, especially because this is it's a could not be true question. So anything in this category sort of could be true or could not be true questions. You should sort of think, instead of thinking, how do I solve this to get a single answer? If it's a could be true question, that's sort of telling you that there are multiple possible answers. And so what you want to be doing is thinking, okay, what is just the bare minimum I know? And so instead of trying to set up equations here, I'm just thinking of what is the most general thing that I know has to be true about these remainders. And so I know if we're dividing M by 5, then N, the remainder, can only be 0, 1, 2, 3, 4, 4. And likewise, if we're dividing this number S by 12, then your remainder T, and we'll write out all of the possibilities here. If we're dividing by 12, it can only be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so this is really all we know about N and T, that these are their possible values. And so if this is really all the information that we can glean about our remainders, then we should be able to answer our question just based on this info. And so which of the following could not be the value for N times T? So could our remainder be equal to 0? Absolutely. If N is equal to 0, then T can be pretty much any one of these possibilities. And that would give you a product of 0. What about 22? I see if N is 2 and T is 11, that should work. So 22 is a possibility. And remember, because it's asking us which of the following could not be true, we are eliminating the answer choices that could be true. What about 35? And so I see here that T contains a 7 and a 5, and 7 times 5 is 35. However, that is not what the question is asking for. We need N times T. So we have to make this product using one number from each of our groups. And so I can choose a 5 from here, from T, but there would be no 7 to go along with it in N. And I can choose a 7 from T, but there's no 5 in N. And so this does not look like it's possible. And this should in fact be our answer, C. Let's just go through D and E to make sure they are possible. 36. And so 9 times 4, I believe is 36. So D is possible. And then what about 44? And so this looks like this is going to be the highest possible product that we can make, because 11 is the highest number in this group. 4 is the highest possible remainder in that group. And so that is possible, and that is out. If instead E had said 45, that would be outside of our range, and that would be our answer, but they don't. So this is a good question, just introducing you to some of your properties of remainders and how they like to test them. Sometimes we will do some more problems now where we are actually are doing some algebra with remainders and actually solving for some of our remainders in the future videos.